And in today's lecture, we'll see some more details about the water activity only, but that is the groundwater. Image what you have seen in the last lecture, where we call it as the hydrological cycle. And in the hydrological cycle, water flows through the surface, and the processes we have seen as a stream. And there are number of the percentage of water around 0.76 percentage of total water which is penetrating into the subsurface, and it takes the movement towards the downslope. So this water, what it is penetrating into the subsurface, that also does a number of activities on the surface of our earth, or the near subsurface of our earth. So we are going to see that what are the activities. So if you see that the groundwater means all water which occur below the earth surface is known as a groundwater. So this is how we usually extract groundwater from the surface. And if you see the surface, this is the surface where our day-to-day activities are going on. And this is a portion where the water is not saturated. And below that, there would be a portion of soil or rock which will be saturated with water. And this zone, we call it as a this water which is present in this zone, we call it as a groundwater. And the surface or the contact between this groundwater and the unsaturated zone, that we call it as a water table. For example, if you see, this is an open well which you have constructed, and the water which is coming up to this, the water which is coming out from this saturated zone, and it will be collecting in this well that we will be using for our activities. And if you see the character of water in this part, or the soil in this part, this will be mostly saturated with water, whereas in the unsaturated zone there will be water, air and sand grains together, so that will be an unsaturated zone of water. So this water which is present here is doing number of activities on the surface. And one more small concept which we'll be discussing over here. For example, constructing a well here. This is a well what you have constructed, and the height of the well which is almost the same level, or which is below the water table, on the water table height on the upland. Okay, so to show you a better image, I'll take the next here. This is the well what I am constructed, and this is the water table, what the height of the water table, maximum height, or this is the area where the water is recharging. So the water head is high in this part. As a result, this well will flow water by its own without having any pumping. Will be able to get water on the surface. Why? Because of the pressure. Water, you know that when you are applying the pressure, water head, if it is high, the water will automatically flow on the other side. So through this well, water will be coming out, and this kind of wells we call it as an artesian well. Similarly, there are some other conditions in the water table. So here, if you see, this is the main water table. Below whatever the soil present is saturated with water. But in this case, where there is a small water table, which is not a regional one, but it is a small water table or a small storage of water in the subsoil. That is because of this impervious layer. Impervious layer means it is not porous and permeable. So this soil, or the soil type, what it is seen in this part, this soil is not able to transfer the water from subsurface or surface to subsurface. As a result, some amount of water will be storing in this part. So this again act as a water table, but it is not the main water table, but we call this water table as a perched water table. So there is another perched water table which is shown here. So this all we call it as a perched water table, which is not actual water table. The water if you try to extract from this water table, it will not be a continuous source of water. It will give water for some time, and then it will dry up. Okay, so these are the concepts of how our water which moves below the surface. Okay, so 2-3 things. So one is the saturated soil, one is unsaturated soil, and the contact between saturated and unsaturated, where the water is in the level, we call it as a water table. Or in other words, this is the surface where the hydrostatic pressure which is in equilibrium with the atmospheric pressure. So the water which is at up to this level, it is not further moving up because of the it is not further moving up where it is in a equilibrium condition. Okay, so this level we call it as a water table, and I don't know whether you observe this note, the water table which follows the topography. So this is a the plain region, but here is a hilly region. But if you see the depth of the water table, which is almost same, but this also depends on the rock type and all. But in a general terms, the water table which follows the topography. Okay, if you go to the hilly region, there also the water will follow the topography, but there are a number of other parameters which controls, and if all other parameters like rock types and the porosity, permeability and everything is same, then the water will have the same topography, but depending upon the type of rock types and its other properties, it may slightly vary in the depending upon the terrain. Okay, so this is about a general idea about our underground water or the groundwater. Now, when you see this groundwater actually does different processes. Okay, so that processes similarly what you have discussed in the stream also. The stream does erosion, stream does transportation, and stream does deposition. Similarly, this groundwater also does some the amount of activities, and that activity is called it as a geological activity of this groundwater. That is what we are going to discuss here. So the work of groundwater, there are basically two types. So first one, it is a chemical work, and the second one, it is a physical work. Correct. So chemical works, you know that the water is a very good solvent. When it passes through the rock types, there are a number of rocks. Depending upon its characteristics, the water will erode that rocks. And what are these parameters which basically controls whether the water will erode that rock or not? Which are first one, it is the climatic condition, where in what part the water is passing through. Second one, it is the geological structure. Geological structure means whether the rock is completely compact or the rock is having some fractures within it. If the rocks are having some kind of fractures within it, then the water will be easy to pass through that fracture, and these connected fractures will ease the erosion processes, and more cavities can be formed by the erosion. Then the topography of the region, then the porosity and permeability of the rock, then the composition of the rock and the groundwater. What composition is there in the rock through which the water is flowing, and the flow velocity will also depend. Then the temperature and pressure of the region also will control that, whether how much the chemical weathering this rock, the water can do in that particular kind of rock. Temperature, pressure, and the last one, it is the depth at which the water is interacting with the rock. So these are the basic parameters which controls the chemical action of the water. Now, if you see the water which enter into the subsurface, moving through the subsurface and creating number of different kind of geological features or the erosional features, and all these erosional features produced by the groundwater, we call it in a general term that is called karst topography. Which is called karst topography, K-A-R-S-T, karst topography. Why is it called karst topography? Because a complete picture of this kind of features which is produced by a groundwater is studied in a particular region called karst region in Yugoslavia. Okay, so that is the type section. We call it as the type section of the karst topography, where we will find the all details of the this underground water, groundwater erosional features. Okay, so for example, if you see this image, you'll be able to see some kind of depressions in this image. Okay, so this is an indication of the underground cavities or the erosional properties by the underground or the groundwater. Okay, so as a result, if you have not taken proper care of this kind of things, and if you are just leveling the surface and making it horizontal, and if you construct a building over this, what happened to this building? So that will leads to the failure of the structure. If you are able to see this building where it collapsed, this portion of the building which collapsed, okay, And if you see, then there will be able to see a depression, or it is a sinking. What happened? The soil, which is all this part, which has gone in, which has moved down. Why does it happen? Because this is the surface and there were some cavity below the surface, and we constructed a building over the surface. Okay, and this force, what it is transferring into the load at this depth, it was okay, it was taking this, but as the time continues, the structure slowly started creating fractures on this, and at one point this all system collapsed into this cavity. So this kind of features which are produced by the groundwater needs to be studied, or we should be able to understand that structures, that features, these are the natural features. This is not man-made features. These are the natural features which is existing in that area. So this needs to be studied so that we can avoid any this kind of unwanted failure of structures. So this is not what a civil engineer is supposed to construct a structure which will fail in the future, that we don't want to construct. Correct. So there are some typical features which will help us to identify whether this area is affected by groundwater erosion characteristics or not. As I already said, that the erosion characteristic of groundwater basically depends on the rock type and its physical other parameters like physical properties, climate and all. But there are few kind of rock types which are very easy to erode by a groundwater, and one kind of that rock is called limestone. So limestone is basically a calcium carbonate, and there are some varieties of limestones like dolomites and all. These all are the rock types which are very easy to erode by the activity of water. Okay, rather if you are having a granite in one part, and the granite may not be that much easy to erode, so it is having very less chance to produce large cavities below the surface. But an area where it is the subsurface is having a rock type called limestone, calcium carbonate formed rock, so that will be easy to erode. Okay, that all things we need to identify when we are going for the construction. So what are these features which will help us to identify whether this area is a karst topography or it is having some subsurface cavities or not? So that features are some of this. First one, if you see, there are depressions in the on the surface. Okay, so these are the depressions, the almost flat terrain. There is all of a sudden there is a depression. Okay, so if you roam around in this region, then you will see, okay, this whole region, there are number of depressions seen in that part. So these depressions are the indications of subsurface cavities. Okay, so this is a feature produced by the groundwater when it is flowing through this part. It's eroded the rock type, eroded the rock. And what is this rock type? This rock type may be possibly a limestone. Okay, so these rock types are eroded and it has produced a large amount of erosive feature. And the impressions of that, what we see it in the top, we call it as a dolines, swallow holes, or sinkholes. Or these all are the terminologies what we usually use to represent this kind of depressions. And this horizontal form, the horizontal carved feature produced by the subsurface erosion, that is called a caves. Okay, so the caves here, it will have a opening on the surface, but it will usually have only one opening in the surface. But if you have both the sides are open, then we call it as a tunnel. Tunnels are the openings which will have one entry point and one exit point, both. But in this case, it was only the entry point, but there is no exit point. It is not connected to both the sides. So this is called a cave. Okay, and here in this part, if you see, there is a stream which is flowing on the surface and it suddenly disappears. So this is an indication of what? Okay, subsurface erosional feature or the karst topographic feature. Okay, and if you see one more thing, this is called a blind valley, the valley which comes and it suddenly disappears. So the valley disappears here. This is called a blind valley. And this river which is disappearing in this part, which must be flowing below, which must be flowing the subsurface, and which is coming through here, and it is now coming out. Okay, so this becomes a giant spring, and it's contributing to this river. Okay, this kind of features which actually indicates, yeah, there are some subsurface features which are controlling. So when we are going to construct, we are going to decide this area for the construction purpose, some construction purpose. For example, if you are going for a building to construct here, so this area needs to be taken into consideration. There are a number of things what we can do. One thing is that if you understand this region completely, okay, now I understand, okay, there is a karst topography, and the karst topography is basically on the rock type. I understand this rock type also, this is a limestone. Then I see that what is the characteristics of this is the surface of the region, and within the surface there is some around 10 meter, there is this particular kind of rock what is called the limestone. Okay, and this limestone is having all these features like the cavities and all, and this is the feature. So this is the features what we see. This is an open erosional feature produced by the river, and this surface now I am going to consider for the construction of something. As a civil engineer, I am going to construct this region for the construction of something. But this much depth, if you see that the top of the cavity or the opening, okay, so this much depth if I see, this is safe, okay, but the construction of a building at this surface is not safe, because this load it may not be able to take, and this part also can generate some number of small cracks, and finally all these things can collapse into the opening here. So what we can do is that now if we are identifying this area, and as we know that as a civil engineer, if you are looking for only, if you are saying that only I will construct in a very proper environment, proper conditions, and if I'm getting a very good basement rock, otherwise I will not construct anything on that surface, then it may not be a possible situation for us. So we may have to sometime find out a solution for this trouble. What is the solution? The best possible solution is to go for a deep foundation. Okay, deep foundation means we are going to penetrate the entire limestone terrain where the groundwater activity is there, and my foundation is going to now rest on this rock. Now conditions apply that this rock should be strong enough to take the load. If this rock is again the same thing, then we don't have any other option. We may have to entirely cut this all rock type from this area and to fill it with another concrete or any other solid material. We need to go for the ground improvement techniques. It is not possible. Compaction and all that things what you are using in a normal condition may not be possible for to apply here. Rather, the only way we may left with cut all this area and take it to the completely take the area, take the rock, remove the rock type and fill it with a good rock or good soil, and then go for the foundation. Okay, so these are the number of different possibilities what we can know, but the key to this aspect is that understanding the feature. Okay, whether these things are there or not, if a ground the subsurface is having a karst topography or not, an erosional feature or not. If it is having an erosional feature, then there are different options we can go for a solution, but identifying that feature correctly is the key to the success of the project. And if you're not able to, if a civil engineer is not able to identify the feature correctly, then that may lead to the failure of the structure. Okay, so this is the karst topography. Similarly, what you have seen the chemical that this all features what you have discussed right now. This is basically the erosional. These are all basically the erosional features produced by the groundwater. So similarly, there are number of depositional features also produced by the rivers. So one depositional feature which is produced by the river, that is called a stalactite. Stalactite is nothing but which is a feature which usually seen in the caves. Okay, for example, this is a surface and there is a cave below the surface. Okay. So water which is flowing on the surface, that will start penetrating into the soil or the rock, and when this is an open cave space, this water which is coming from this part will start dripping on the from the top. So this water which drops from here on the top will have some fine grains of calcium carbonate or any other chemicals on it, So what happens in slowly it will drop the water, but it will leave one single drops of one single piece of this calcium carbonate in the top. So this process will continue slowly. It process continues very slowly in grain by grain, and it takes a structure and it forms something like this. Okay, so this is called a, what is it called? It is called a stalactite. Okay, stalactite is the feature which is growing from top to bottom. This is the top portion of the cave, and the growth of this is towards the bottom. Stalactites start continuously form from this stalactite. This started accumulating and start growing in the upward direction. Okay, so when water penetrating through this rock type and falling into the cave, so there are two simultaneous growth processes which is happening, one from the top to bottom and another from the bottom to top, and the thing which is growing from bottom to top, it is called a stalagmite, 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 and the one which is growing from the top is called stalactite. And in some cases these two things will grow, and this will grow from the bottom, this will grow from the top, this will grow from the bottom and top, and at point this both the things will combine and it will form a continuous structure from top to bottom. Okay, so this we call it as a column. It's the same structural term what you are using. So this is a column which is produced by the depositional feature of the groundwater. Okay, so these are the depositional features produced by the groundwater. Okay, so stalagmite, stalactite, and column. Okay, so these are the basic things what we are in case of the geological process of groundwater, and basically we are talking about the mechanical process which produce erosion and which produce deposition. And similarly there are some amount of mechanical process also this groundwater will do. Okay, mechanical process means, okay, this is a hilly terrain, and the water which is flowing on this, and the water started flowing through this hill towards the bottom, and this movement of water in this hilly terrain, which may leads to the decreasing the stability of this particle, and this may all fall down, or it may start moving towards the downward direction by the activity or by the force of gravity also. So this gravity and the water will act as an ingredient to improve the to increase the or decrease the stability, and it will leads to the failure of the slope. We generally call it in other way, we call it as a landslide, or in geological terms we call it as a mass wasting. So this water which is flowing on this part is actually giving some role in this activity also. This processes is called the mechanical process of the river. So we'll study this mass wasting in detail in next lecture, I suppose, in coming lectures. So where we'll discuss that what are the different kind of mass wasting activities which are happening.